Welcome to another episode of We Are Carbon. I'm Helen Fisher and I'm joined by Dong Xiao to explore his work within the research and development of a stable production method for obtaining purified hydrogen gas out of waste plant matter. It's fairly well known that methane can be produced from the process of biodigestion, where the activity of microbes consuming organic matter has an output of gas that can then be contained and utilised. Prior to his focus on hydrogen, Dong was researching the shortcomings of biomethane. It's actually a process that's very inefficient due to the slow speed of digestion and the amount of material that just never gets used up. So, with a specialist understanding of microbial groups, Dong and his team have worked on developing a process of digestion that's directed towards yielding hydrogen instead. The efficiency increase is astounding, obtaining gas from the entire volume of plant matter within hours rather than months. It's offering huge potential as a source of renewable energy that also quite excitingly can play a role in a circular economy, as byproducts from the gas production can go on to be used as valuable materials. It is, however, a far more complex technology than producing methane and requires very fine-tuned control and usage. Dong is sharing insights and an overview into his work here, as he is very much up for open collaboration and partnership to ensure that this technology can be continually developed within a range of applications across the globe. If you have a technical or working interest in this discussion, then I'd recommend watching through the video version, where you'll find subtitles and chapter markers to follow along with. New episodes of this podcast are added every other Tuesday, and you can find them on YouTube and your favourite podcasting platforms. And don't forget to subscribe to keep up to date. Right, let's get stuck in. Hi Dong, thank you so much for joining us. Would you be able to get us started with a quick introduction to yourself and your work?
Okay, I am a staff in China University of Mining and Technology. I start to do the research for the biohydrogen. My work in this area is start from the around 2010. In the beginning, it's by method. But when we deeply start for that, we are thinking, first of all, the process is too long. Secondly, can we to get some more new energy and clean energy out? So from 2016, we start how to get the hydrogen. So I think we are very lucky. We are very lucky for my team. And in 2019 to 2010, we successfully to finish our job and to get very stable biohydrogen yield. So this is what I research.
That's fantastic. It would be fantastic also if you could offer us an explanation of how it's possible to obtain hydrogen out of organic waste.
In the beginning, we focus more on the fossil stuff. It's like coal, and like the petrol. For this kind of stuff, how to use microbial treatment to generate hydrogen. So in our research, we focus more research on the underground microbials group. So we extract the hydrogen microbials from the coal seam and then to use it. And with some friend suggestion like Crystal, and does it possible to use these microbials to treat the organic stuff? It's like the tree, the leaves, and the grass on the ground, and some agricultural waste. So we start to work on it. For the microbials, to use what I research in my area, they normally to use the sugar. To use a kind of sugar, but the sugar is not only the traditional sugar like the candy sugar, no, not like that. It's like the starch and like the grape sugar and anything else. It can be used, and with the biofermentation and to break down the molecules to get the hydrogen, and sometimes a little a part of the carbon dioxide will release also. This is a bioprocess way, so we cannot escape the carbon dioxide. It's always to be used. The only difference is how many carbon dioxide will be used. This is a very key question for our research. And then some the organic acid also can get. So we will use this stuff for the soil restoration, and also to the mining area, the environment protection.
Okay, so it's a really very big project and there's encompassing a lot of aspects here. So you originally started with the idea, the concept that you could obtain hydrogen from fossil fuel extraction, from coal mines.
Yes.
And you have later researched that it's possible to obtain that hydrogen out of starchy sugars within plant matter. So you're breaking down those molecules within the plant matter and extracting the hydrogen so that that can be a fuel source. And then as a off-put, there's also carbon dioxide and organic acids. How then, you say this is a biological activity, this is about microbes breaking down the plant matter. Could you explain a little bit about what they're doing? Is it just their natural process of eating and then excreting waste?
Yeah, this is natural. For these microbes, they are everywhere. They not only in the coal seam, also they in the soil, around us, and also it's a take for example in the cow insect system, it also exists, because this kind of microbe is very important. It's very important for the bioprocess way in the nature. They always compound or cooperation with a different kind of microbes to supply the hydrogen, carbon dioxide, organic acid, and some organic other kind of compound for the further process. Take for example for methane. For methane organisms, they will use the fermentation productions from the hydrogen and the carbon dioxide and some kind of acid, and go on to finish the process to produce a methane. So the only difference is how we use it and where is it come from. And by the way, the biohydrogen microbials, they are abundant species, have a lot kind of species. For our research, we will try our best to find which is the best one and more stable, more easy to use, and safety, and also have a stronger ability to yield more methane, less carbon dioxide, and also stable and safety for the environment, for the human.
Okay, that's very interesting. So the methane production that people are probably far more accustomed to in a biodigester, that's a process that's depending upon microbial activity to output methane. And what
Yes.
you're working on is identifying, out of the abundance of microbes available that can produce hydrogen, you're focusing on identifying which ones are very most suited to optimize the process.
Yes, it's true. We also, yes, in the beginning we research for the biomethane, and then we research for the biohydrogen, and our target is how to. In the beginning, we are thinking how to let the biomethane process can go quicker. So based on this idea, we divide it biomethane. From the middle is the biohydrogen get out, and then we will extract the hydrogen out, and then the carbon dioxide and the acid will go on to supply for the methane organisms, let them to finish the next step work.
Yeah, it is very fascinating. I'm want to make sure that I fully understood this then. So the methane process, it requires a breakdown of the molecules that then the microbes will continue that process, and it's a more lengthy process to produce methane. But with the
Yes.
hydrogen, it's at a more immediate state where you're simply, they've broken down, the hydrogens come off, and then you're capturing it at that point rather than it being reutilized into the methane itself. So methane contains hydrogen, and you're preventing it.
Yes, you can think by this way.
Yeah.
But the bio process is more complex. And in the process, yes, the hydrogen is the middle, in the middle process or middle production. Yes,
Yeah.
you're right.
Fantastic. So in a really simplified form, the molecules within sugar include carbon, they include hydrogen, they include oxygen. And methane includes hydrogen and carbon also. So it's
Yes.
kind of, in the methane production, it's breaking down the sugar and then reutilizing it as methane. And in the hydrogen production, you're taking a step back from that and you're simply harvesting the hydrogen, which is very exciting because hydrogen is more difficult to isolate as a molecule than the methane. So there's a relationship between producing hydrogen and producing methane. Could you help us to understand how you go about deciding, how you go about controlling what the output is? Is it a case of the type of microbe, or is it the equipment and the process that you use?
This is a little complex. We get the hydrogen bacteria from the methane groups. So it's like what? It's in the beginning, it's really like the small box. They are a unit, and then we broke it. So the hydrogen go out, and we stop the methane. The key point is how to make it stable, because it can go back anytime if controlled not in a good way. So first of all, we need to study what's the factor for the bihydrogen microbials, what they like. And then we also need to check it out what the methane microbials like. They are the group, but they not always too close. They have the cross, but they are not then connect every point. So in some point, the bihydrogen microbials, hydrogen microbials, they like, but methane they don't like. Methane one they don't like. So we need to find this point out and then to broken it. After broken, we keep on this condition. So what are we working now? We don't want to keep this condition for a long time. It's like the control process. It will be hard to control that. This is required for the technique, for the nutrition control, also for the like the cultural factor control. It's more and more complex. So our second research is remove the methane stuff out and left the hydrogen in this group only. But actually, it's not easy because the hydrogen bacteria is not one strain. It's a group. It's also a group. We separate from one group to move another kind of microbe out and left the whole process. So that is not so easy. I prefer to call it it's a dynamic balance.
Okay, that's very interesting.
So it's not very stable process, but it's always in a balance, and we just find a balance point. The whole process really working. It's like the two hand. It's always in a balance, and if in a balance, don't worry, the hydrogen always go out, and if it's broken, so the two result, the methane totally go out, and then the hydrogen microbials maybe died. They are not working. Another balance, they connect again. So everyone we don't want to get. So our research is how to make the balance in a good condition. Just is like the dynamic balance. Yes.
Okay, very, very well explained there. So this is a case of the different microbes, and there's many different strains, they have different conditions that they love.
Yes.
And you're trying to really research and find out what the optimum conditions are to make the hydrogen producing microbes thrive, but not be too supportive of the methane producing microbes. Is that about a sort of good understanding, or is there something I've missed there?
You are right. You are right. You are so clever. You are right.
Fantastic. No, it's like very, very fine, detailed work that you're doing then in terms of understanding and identifying the differences between the microbes.
Thank you.
So you have to understand how to identify them, and then how to identify what the conditions are that they love and that they're very productive in. So in terms of if we were producing hydrogen instead of producing methane, is that a faster process? Is that a faster way of obtaining energy out of the material?
This is a very good question. It's much more faster. Take for example, we normally to use the agricultural waste to produce methane before, right? And how long the process? Normally need 25 days at least. But for
25 days.
at least, but for the whole process, it need 3 months and even more. So in the beginning, the gas yield very quick and then it slow down. But in one point, the economic data is not good. So this is reason in around 30 days, we stop it. It's because the gas yield too slow. But it's continue to work on that. The whole process is need at least 3 months. But for the biohydrogen, it's much more quicker. The same material to finish the process with our best control, only 8 hours. Okay, it is like this. Only 8 hours. The whole process finished. So this is a big difference.
Yeah, that's huge. So in terms of the same volume of material, you're obtaining gas from the full usage of that material in 8 hours, but it would take 3 months from the methane, which just is, you cut the process off after 30 days because it's so slow after that. That is, I'm not going to do the maths off the top of my head, but that is phenomenally quicker. That's a huge gain in speed. Does that mean that this is a more economically viable process than producing methane?
Yes, of course. Take for example, if we want to build a big system, just as an example, to digest maybe 1 million ton of the agricultural waste, we need to invest so many money. We also use the box as an example, so many money to build the whole system. But for the biohydrogen, it's much more quicker. So how much we need to invest on this? We don't need so many. We just maybe the cup so less is enough. So the financial data is much more better. But for the technical skills, it's like the worker skills and the control ability, and also include the auto control system is much more important, because it's like we can make an example. If for the biomethane process, it's like the normal car. The biohydrogen is F1 and maybe jet.
So it's not for your average user to go driving around in. You need a bit of skill.
Yeah, we need that skill, or we need the auto system to control that. So in this process, and when we realize in one step is gets wrong, not in a good point, when we to action on it, it's late.
Okay, so it's so fast that
Yes.
there's no room for error. Yeah. Yeah, so in terms of the space and the time that's required to obtain the gas, that's a whole lot more, that's smaller than methane by a long way. But in terms of the complexity of the system, this is something that requires very well developed controls and facility to be managed and obtained.
Yes, we are working on it, and the basic system we still use the methane digest system. Yes, with agricultural waste to produce methane. We based on this system to do some develop. We are still working on it, and to let this system can be more and more smart.
Yes, so there's a lot of developments going on and all the different aspects of this work. I think it'd be interesting. We've compared it to sort of methane, and there's potential for this to be far more productive and far more economic in the long run. How does it compare to different sources of hydrogen as a fuel source? Because there's many ways of producing hydrogen, but they're known to be expensive. So how does this compare?
We have a lot of way to generate hydrogen. It's like we can use the electric, right? First of all, just use electric power, and as I know, lots of company and in some countries they began to work on it, and the hydrogen content is very high, and then the co-production is oxygen. So this is first technique, and second, we that is kind of the co-production. It use in a lot of the chemical process. It also can yield the hydrogen, and by the way, we also can use like the methane and like the coal to use the chemical process to yield hydrogen. This is also work. So blah blah blah. We have lots of kind of the technique to do that, but the bioprocess is one of technique. Um, for the bioprocess, compare with the electric one and the chemistry one, it have a big difference. Why we work so hard on it, and we invest so many time and so many money and to deep research on it, because they are very different. For the hydrogen yield, the electric technique is the best, because only hydrogen and oxygen will be yielded. The hydrogen content very, very higher. So that is very easy to use for the car and for some special areas. That means they require higher hydrogen quality. But it's too expensive. We need to generate the electric out first. So how to get electric power? Thermal and hydro, right? After that, we use solar. We also use the wind. But the solar, they only work in daytime. At night, no sunlight, the solar not work. And here we don't talk about the energy storage system. We only based on the very raw condition. So for the electric price will control the hydrogen cost. This is the first. And the second is the chemistry one. The chemistry, normally when we produce, we will have so many productions, co-productions. The hydrogen is a one important production, but in the process, they also have so many like the sulfur hydrogen and any other kind of compound. It's so difficult to purify it. So in the basic cost is low, but in the purify process it's expensive. And by the way, like some compound is dangerous or harmful for the hydrogen cells and other kind of the stuff. But why for the biohydrogen is very special. First of all, compare the speed. It's lower than chemistry one. The chemistry process always quicker than the bio process. So this is the reason we need to work hard to let the process can be quicker, and quicker, can compare with the chemistry industry. So this is first. Second, based on different kinds of the nutrition we use, and the hydrogen will be very purified. So in our technique now, what we get is only hydrogen and carbon dioxide. And the sulfur hydrogen is very, very low. It can be ignored. the content almost zero. So for the left materials, it's only some water and something. So to separate the hydrogen and with carbon dioxide is very easy because the hydrogen molecule is too small. And compare maybe the carbon dioxide is like the basketball, right? So it's very easy to separate them. And the bioprocess is also cheaper. We don't need so many energy to power to heat it and to maintain the process. So this is cheaper. The only way is we need to work hard to how to let the bio process go quicker, to let the economic data go better. This is best.
Yeah, fantastic. So there's a world of options out there, but to sort of summarize it, producing hydrogen from electricity, it's either going to use fossil fuels or it's using a renewable energy source that we don't quite have that constant ability to renew and have that. So it's tied to that electricity price if you're going to produce hydrogen in that way. But the biological process, it's got the output of carbon dioxide, but it's being captured, isn't it? That carbon dioxide is being captured in the process rather than released into the atmosphere. So on that sense, is that being reutilized?
Mm-hmm. Yes, you are right.
So you mentioned that the organic matter that can be used, it has to be starch-based. Could you give some real-life examples? You've said animal wastes. Can food waste also be used for this?
I have some ideas on it. Firstly, I prefer to use agriculture waste. It's like the corn straw because it's how to use it is very important. We can use the corn straw to feed the cow, but we still have so many. Every year we plant so many corns, so we still have too many corn straw we left, and in somewhere they burn it. But now we give another solution. We can use it to generate hydrogen. This is one solution, and another one is like I'm in Argentina now. Argentina is a big country to produce the sugar. So in this area, they have lots of the sugar cane. But after to produce the sugar cane fibers also contain lots of sugars. It's not easy to extract out by the normal process. But now we can use it to generate hydrogen. And then we also can get lots of high quality fiber to make the biomass materials. So this is the first. Secondly, I'm really very happy to let this technique to support for the organic farmers, because in the farming process, we always have so many agriculture waste. We can use that with a very small system to generate hydrogen to support the farmer to use. Yes, hydrogen can use for a lot, can use to generate the power, electric power, and also can use to burn it to get the heat. So something, different kind of use. This is another one. But for the animal for the animal waste, and now it's not easy to use. The reason is a lot. First of all, in the manure, it contains so many microbes. And when we add the hydrogen microbials in it, the abundance is important, except we give a lot. After that, if we only give a little, like what we use now, and they will disappear in the microbe groups, right? So this is first. And secondly, in my system, we need to control the nitrogen compound. So this is the reason. And now we prefer to use the animal waste to produce methane directly compared with hydrogen, because the process is much more complex.
Yeah, that makes a lot of sense. So, with regards to having a good partnership with a waste source, is it very beneficial to have a large source of the same matter,
Yes,
so that you
yes.
can control it more easily rather than a mix.
Yes, we need to separate the waste in different class and then to decision how to use that.
Fantastic. So I can imagine that there are quite a lot of opportunities then to create the fibre. You said that this is an off-put, a byproduct is the fibre from the plant matters left behind. And I think you said that can be utilised into building materials or construction materials. Could you talk about that a little bit more? I think that's really interesting as a byproduct.
Okay, um, I am working in a mining university. So we will focus on what? On the mining process. It's always have a very unhappy stuff happened. It's like the soil go worse, the environment being polluted. We need to restore it. So to develop it. So we have a schedule like this way. In this kind of area, we prefer to plant the carbon 4 plants. And the carbon 4 plants, they will grow up very quicker with a lot less nutrition support. So we can collect this kind of straw to generate hydrogen. They are very close to the corn straw. So after the hydrogen being produced, we will left some straw fibers because the microbe is impossible in so short time to use everything. So for the deep decay stability is a little weak than the methane microbial group. So in so short time, they only can use a part of compound, and then for the fibers will left. These fibers after bioprocess is more soft. It's not like the raw one, very easy to broken, but it's more soft. And now we will use these fibers to produce the biomass board, and also can use for the building. Yeah, Crystal is also working on this. It's like and not only the corn straw can use. It's a lot kind of stuff like the corn straw, the sugar cane, and another kind of we have lots of resources. Everything can be used.
That's wonderful. So this is very much a part of the circular economy in that you can grow the materials and produce the fuel off them, but also then repurpose what's waste
Yes.
from that process and turn that into a valuable building material that then in a sense is getting locked up. So the carbon is in those fibres and that's being locked up within, say, the wall of a building or however that material is being utilised. How else is the carbon dioxide, when you've got the byproduct of the carbon dioxide gas, in what ways can that be repurposed?
This is another good question. And in the process, carbon dioxide is co-production, but it's very purified. So we have 3 ways to use that. First of all, I prefer to use that to make beer. And the soda water is indeed work. So this is first we are working, and second way we will in some area we will to make the gas carbon dioxide to dry ice, and then for the delivery system to maintain the temperature for some special requirement. This is second. And third, we also to use the carbon dioxide as a kind of the compound material to mix with look, after the coal burned, we can get a lot of ash. And then how to treat the ash? Now we use the ash, carbon dioxide, and some other kind of microbes, not microbes, materials. Mix them together and to make kind of the bread. In the bread, the carbon dioxide sealed in it, and also it will be help let the bread go harder. More important is it can maintain the temperature. It's much more better than use the pure air.
Okay, so there's a number of uses.
Yes. Yeah, 3 we use now.
Yeah, that's fantastic. And is that carbon dioxide very useful because it's so purified?
Yes, and stable.
And stable, yeah. There's another byproduct that you mentioned. You mentioned organic acid. Is there anything that gets utilized for?
We will process it, and this kind of stuff can use for the plants. Just now we talk about we will do some work for the destroyed soil area, right? We plant some carbon-4 plants, and then we use the plants to get hydrogen, carbon dioxide, and fibers. And sometimes we will also get some acid, the organic acid. So we will make the organic acid to a acid salt. After that, in the salt, like the phosphate, the calcium, and the iron, the content is very high. We use this as a fertilizer, go back to the soil to develop the soil and support the plant to grow up. So we work by this way.
That's actually very beautiful because it brings it right back round to the soil and feeding the soil that those materials came from in the first place. So that does, the whole process seems very nicely circular, and certainly not what we think of when we think of producing energy. It's very clean and very organic and natural.
Yes, yes.
Does the process in terms of producing the facility that is capable of producing the hydrogen, does it work at various different scales, or is there a particular scale that's it's most well suited to?
Okay, I prefer to talk about this by this way. I service for some huge the bio-methane system to use the animal waste, agricultural waste, to deeply use the agricultural waste or the animal waste to get energy, and then to let the agricultural chain can going on, and sometimes not high pollution to the surrounding environment. But I prefer to let the system not too huge. It should be, I think, in my mind, the future energy system is not like now. It's not like the huge power station. It should be the separate power station. Because we move the fibers or we move the straw from one place to another place, it's very expensive. For a short distance, it's okay. But if we transfer or deliver 50 kilometers, the price is so high. Maybe we need in a certain area to build a small station and digest the waste materials. And after that, we can connect like the bi-hydrogen system together or electric system together to let every station to be like the power station or clean fuel station to supply the surround. And for the left power, they can share and connect each other to use. I think this system is better. And by the way, I don't suggest to build too small system. It's too small. The financial way is not very good. But sometimes it's work. Take for example, if we have a farmer, they living in a mountain, and he can use a small system to digest the waste, to get hydrogen, to get the power. It's no problem. Just the power cost is a little higher.
So when you say this is small, this is just the output of one farm.
Yes, support for one farm. Maybe the system only 1 square meter. The volume only 1 square meter. It's very small. It's tiny.
And what would be the largest facility that you've seen in use?
The largest one I built, one tank is 8,000 cubic meters for one tank. and in the system have 10 tanks.
Wow. So 10 tanks of that size.
Yes, yes.
Yeah, so that is really huge compared to these are two extreme sizes, but in your personal vision and your absolute kind of epitome of what would be the best use is the system that requires the right scale for the location, that the waste doesn't need to be transported, the fibres aren't being transported too far, so that it doesn't negate the benefits, I suppose, with all that travel.
Yes, you're right. I will suggest the system the better bigger than 100 square meters and smaller than 1,000. It will be better. Uh, I think it's more easy to control. The yield rate is higher, and the energy requirement is low. And also, this station can be more automatic. So huge is not easy. So I don't suggest the huge one, except we had to do that. We have no choice. And for so tiny one, I am working on it. This is not very economic, but it's indeed very helpful for some special locations like the farmers. And the farmer just put a little, like the straw, grass, the leaves, whatever, just put in it and get the energy. So it's beautiful.
Fantastic.
And yes, in some area, it's like in our some special mining area, the power supply is a little difficult. We can use this kind of stuff to support the power in emergency or for some special utilization. So to support the mining system can keep running. Yeah.
Yeah, that's lovely. It sort of sounds perfect for a circular economy on a more sort of localized level. That production of energy in hand. Has it been used in, say, a factory where it can power the operations there and fuel itself off their own waste?
It's still under design. And for the small system, it's already used. In my campus, we have a model. It's working for a long time now. And I also support some farmer in China. That is very simple system. And the stable is, be honest, that is not stable. It's some skills. But it's indeed work for the greenhouse to support the greenhouse energy and also support the heater. Um, and we are scheduled to build some project in China, and also we have a contact with Indonesia, Australia, American, Canada. We will support the farmer or some like the agricultural companies to use how to use their waste to generate a heater, to generate power, to support the whole system. We are working on it now.
That's wonderful. And does this have the ability to store the hydrogen for use when it's a different time to be used later? Or does it have to be fairly consistently utilized rather than stored?
This is a so good question. This is very big question for hydrogen to use. Here I cannot say my idea is correct, very correct, but I think to storage hydrogen is very difficult. First of all, the molecule is too small. We use the traditional storage method. The hydrogen will be very easy to mess it out, to explore it out. Very difficult to keep in a content. Whatever is fiber, is rubber, or is a rubber system, or use plastic, or use like the iron. Especially on the higher pressure, it's the hydrogen is really hard to keep. This is first. And the second is too danger. The hydrogen not like methane. The methane blast limitation is very narrow. But hydrogen is too wild. In another way, we can think the hydrogen mix with the air, it will blast. So for a long time to storage hydrogen, that is not easy. So in my mind, after we have some choice like this. First, when to use the hydrogen. Why we let the bio process go quicker? It's because, take for example, I build a hydrogen station. I can do evolution when is a higher volume hydrogen will be required. So when is the right time, I let the system to work. I just use a small storage system. It's enough, right? And then after the hydrogen be yield, it will be pressure, and then to support for the car. So don't for a long time to storage. This is first. We are working. We can build the bio hydrogen station. And the second, with the better to use it directly. It's like the factory. Don't try to storage for a long time or with a huge cycle. After to get it, to support to the hydrogen cell directly, or to burn it directly, or to other kind of use directly. It will be much more better. And in the future, how the hydrogen way to go on is a little complex. Is purified hydrogen will be the big market, or like the hydrogen, high hydrogen molecules, like the ammonia? Which one will be the future? We need waiting, and we also need to work on it. I think ammonia may be much more better than hydrogen to transfer to storage.
Thank you. That's fantastic. So, with regards to designing the system, this is another factor that has to be taken into account, is creating the right size and the right speed for it to be utilized locally and at the right sort of pace.
Yes, and the right speed also very important. Sometimes we don't want it too quick.
Well, there's a lot of considerations to go into this, and it sounds like the research is continually developing. And you've mentioned that you're working with a lot of different partners across the globe, which must be exciting to bring lots of opportunities to put this into different applications. Are you always on the lookout for new partners, and how do people kind of go about that if they're interested?
Yes, I prefer to get open cooperation. It's like now I already have a cooperation with Australia, and yes, with Crystal team, and get a cooperation with some American friend, and also now I'm in Argentina. They are also interested on this. This is big agricultural country, so how to let the technique to compound with the real condition in Argentina, and let the farmer can get the cheaper and the high efficiency, more clean energy, and at the same time how to use the biotechnique to support the agriculture again. So this should be very interesting topic. And by the way, I really pressure so many friends we can connect each other, because the research is not only stay in the laboratory, not only to face the computers. We also need to talk with the different people. We all always have some flashpoint go out. It will be helpful for everyone. So this is my attitude. I will prefer to open the technique to share with my friends in the whole world. We work together.
How wonderful, because it sounds so important and so much potential within this. And it's at a time when it has fantastic need, really big need, really big opportunities. Thank you so much for sharing all of your work and for sort of opening the door to this discussion. It's been really, really interesting. If people do want to get in touch with you, is it possible that we can share your details within the description?
Yes, we can, of course.
Fantastic. Is there anything else you'd like to add that we've missed?
Anyone, and if we can want to get a cooperation, I will do my best. And you are welcome to China. And also we can meet in another countries like Argentina now, or Australia and somewhere. And normally we will have some conference. It's in different kind of conference in different place, we can have a talk. And with a deeper cooperation, we will get the technique go quicker. Thank you, Helen.
No, thank you. It's been a pleasure. And thank you for listening to this episode of We Are Carbon. New episodes are added every other Tuesday, so don't forget to subscribe to keep up to date. It's a huge help to the show if you'd like to add a thumbs up or a review on whichever platform you're listening on. And let's keep figuring this all out together.